Hi everyone! We already know that angles can be measured in degrees. Well, in this video we're going to learn another angle measure and it's called radian. Before we define radian measure, we need to refresh circumference formula. Remember that circumference is the distance all the way around a circle. And we learned that if you take circumference of any circle and divide by the diameter of that circle, you always get same number. And that number is non-repeating, non-terminating decimal that equals approximately 3.14. And we use the Greek letter pi to represent that number. So let's perform a few manipulations with this equation. What I'll do, I'm going to multiply both sides of this equation by d. And that means that these can be cancelled on the left-hand side. So after that step, I only have c on the left, the circumference, and then pi times d on the right-hand side. But what is the other way I can represent the diameter? Well, since diameter is a segment that connects 2 points on a circle and goes through the center of the circle, it will always consist of 2 radii, radius 1, radius 2. And that means that in the equation, we can replace d, the diameter, with 2r. And as I reorder the right-hand side, I get what's called the circumference formula. So circumference equals 2 pi r. Well, after we refresh this formula, we're ready to talk about radian measure. We're looking at a circle with radius r. Now imagine an angle theta that has been rotated far enough so that the distance along the circle is the same as the radius. In other words, we can say that this angle intercepts an arc equal in the length of the radius of the circle. So whenever that happens, for any circle, the measure of such angle is said to be 1 radian. And hopefully you can see that no matter how big or small the given circle is, we can always find an angle such that it intercepts an arc with the same distance as the radius, right? Now you might be wondering how many angles like that measure 1 radian can fit in a full circle. And that is the same as saying what is the radian equivalent of 360 degrees, right? Well, and then from what I see on this picture, I can say that the number of radians in a full circle should correspond to the number of arcs of the length r that can fit around the circle. So what is that number? How many r's I can fit around the circle? Well, that answer we're going to get from the formula that we just refreshed a minute ago. The circumference formula. Remember that we discovered that circumference equals 2 pi r. So that's the number of r's that can fit around the circle. That number is 2 pi. And we can even approximate that number. Remember, pi is approximately 3.14, so 2 times 3.14 is about 6.28. So that means that no matter how big or small the given circle is, you can fit in about 6 arcs of length r around that circle. And now that will help us to make connection between degrees and radians. If the circumference is 2 pi r and the angle that intercepts 1 arc of the length r equals 1 radian, that means that there are exactly 2 pi radians in 360 degrees. When we use radians, there are options how we can denote the units. We can write out radians, or we can use the symbol r for radians. And as you can see, it's positioned same way as we position symbol for degrees. However, it's also common not to write symbol for radians at all. And in this case, it's just a common understanding that whenever a value involves pi, it's a radian value. Let's investigate the relation between degrees and radians a little further. We already said that 360 degrees is equivalent to 2 pi radians. And both represent 1 complete revolution around the circle. But how about half a circle? What is its radian measure? Well, this can be simply found by first obtaining the half circle in degrees. So if I have 360 degrees and that's the full circle, once I divide by 2, that will give me 180, which is half circle, right? Well, if I divide by 2 one side of the equation, I need to divide the other side as well. So from here you can see that half of a circle, which is 180 degrees, is equivalent to pi radians. And now if I divide both sides by 2 again, I'm going to find out that 90 degrees is equivalent to pi over 2 radians. And now you can probably see that using the same approach we can find equivalent degree and radian measures for other angles. On the other hand, there may be some degree measures like 77 degrees, 111 degrees that are not that obvious or easy to convert using the approach that we just tried. For that, we're going to develop a special method that helps us to convert between degrees and radians. And that method is usually based on the equivalency between 180 degrees and pi. Since we know that they are equal, then we can say that dividing 180 degrees by pi radians should be equal to 1. Think about it as when you have same quantity in the numerator and in the denominator of the fraction. And of course I can flip that ratio, right? Pi radians over 180 degrees, well, since quantities are the same, equals 1. So these two ratios will help us to convert between degrees and radians. Let's look at a few examples. So these are the two examples we're going to try. First, we'll need to convert 100 degrees to radians. And then we'll need to convert 3 pi over 20 radians to degrees. And as I already said, we're going to be using those two ratios. Now this is how you want to think about it. First of all, we know that when we multiply any number by 1, nothing happens. 5 times 1 is 5. 10 times 1 is still 10, right? So the conversion is going to be performed by multiplying the given quantity by 1, but that 1 will be represented in one of those two forms. So overall, we are not changing the quantity, we're just changing units. Now, which one out of those two we need to pick? Again, we're doing 100 degrees right now. We're trying to get rid of degrees and create radians, right? So think, which one do I need to use so that degrees are cancelled when I perform multiplication? Well, that's going to be the second one, because here we have degrees in the denominator. So degrees in the denominator in this ratio will cancel with the degrees that we have in the original number. And we will be left with radians only. Okay, so I'm multiplying by pi radians over 100 degrees. And again, that represents 1. So I'm not changing the overall quantity. But at the same time, degrees are being cancelled. And I'm only left with radians. Of course, I will also simplify numbers here. Both 100 and 180 I can divide by 20. So that will give me 5 in the numerator and 9 in the denominator. Which means that the answer will be 5 pi over 9 radians. So 100 degrees is equivalent to 5 pi over 9. Now let's try our second example. Here we have 3 pi over r radians. I'm going to add the symbol. And we need to convert to degrees. This means that we want radians to be cancelled. And since I have pi and radians on the top, I'm going to use a ratio that has pi radians on the bottom to cancel them. The given number I will be multiplying by 180 degrees over pi radians. This will allow me to divide out pi radians and simplify some other numbers. Okay, looks like we can divide out 20, so it's going to be 1 in the denominator and 9 in the numerator. Let's multiply out everything we have left. So that's going to be 27 degrees, right? Don't forget that here we have that degree symbol. Well, that means that 3 pi over 20 radians equals 27 degrees. So yeah, that's basically the way we perform conversion between degrees and radians. And one last comment that I would like to add at the end of this video is that although radian measures are often given exactly in terms of pi, they can also be approximated using decimals. For example, this angle here that measures 3 pi over 20 radians. To approximate, I just have to use calculator. I would take 3 multiplied by pi. Many calculators have a button that's called pi, and it stores good approximation of pi, or I can simply type 3.14, and then I'll divide by 20. And that's approximately 0.471238 radians. And I can always round it to the needed number of the decimal places.